live streaming. Okay, so. All right, so what we're going to do today is cover taping out and how we go from a 2D plan to actually taping it out in an accurate way on the stage. So we've got a really, really simple theater here and a very, very simple set, right? There's a wall, there's a door here, another wall, door, another wall, and another door. The traditional method that most stage managers are taught is called the over and up method, and it relies on the center line and the plaster line. This is a horribly inaccurate system. Anybody who's ever done this knows that when you're all done taping out, it's some sort of mangled mess on stage that doesn't actually resemble the ground plan. And there are two major reasons for that, right? Because if we wanted to find this point right here on the corner, right, we're just going to start with that because it's out in the open, it's easy to get to, right? And easy to demonstrate. If I wanted to measure and tape out that point, what we would do is if we use the over and up method, we would take our scale rule, right? And if it's in half-inch scale, we would take our half-inch scale and we would lay it on here, and we would measure the distance from that corner to the plaster line in feet and inches. Here's the first problem. I'm doing my best to make sure that this ruler is perpendicular to the plaster line. But I'm in half-inch scale, so if I'm off just a little tiny bit in my orientation of my scale rule, I'm possibly off inches, right, in the real world. Same thing goes this way. Now I'm going to measure the same point from the center line over, and I'm going to annotate that. Again, if I'm not perfectly parallel to the plaster line and perpendicular to the center line, right? What happens is we're off by a magnitude of many inches. It's very easy to be off by inches, especially if it's a quarter-inch scale ground plan. Like the smaller the scale, the easier it is to get off. But what we do is we record all those measurements and all those distances, and then we would take our drawing and we'd go into the theater, and then we would go ahead and if you're, depending on where you are, if you're taping out in the theater, you might snap a line, right, with a chalk line across the plaster line, so you have that as a reference, and measure in the middle, right, and then try to snap a center line, because you need those two reference points. If you don't snap your center point correctly, your center line correctly, if you don't do that right, and it's not perpendicular, then everything else is going to be off because you measured it, right? And this isn't sitting center in the space. On top of that, we're going to then take our tape measure, and when we get big sets, right, if this is 15, 20 feet, 30 feet, we're doing the exact same thing. One of your ASMs is going to hold it at the plaster line, and you're going to measure out as best you can, right, the distance that you measured in your scale rule. You're gonna make a little mark, and then you're gonna repeat the same process from over here, from the center line and over. And again, keeping those tape measures actually parallel and perpendicular to these lines of reference is pretty near impossible. So this is why when we traditionally tape out a set using what's called the over and up method, it doesn't come out right. And has everybody had that experience? Did you do all your careful measurements, you go in there, you snap your lines, and then you're like, that doesn't look quite right. That's why. The method we're going to talk about today is called triangulation. And it's actually, if you have one of these, which we all do, right? It's how your GPS works. Right? This is how the world, your phone knows where it is in the world, is actually via triangulation. There are satellites in geosynchronous orbit that are triangulating your position constantly. And what triangulation, the foundation of triangulation is the concept. It's not the concept, it's the truth, it's the reality that if you have a triangle that is length A and length B and length C, right? I'm not even getting into Pythagorean theorem, that's not a right triangle. That there's only one way those three lengths can possibly come together. Right? You can't shift it and move it in any other way, right? It's just one of the laws of mathematics. It's actually trigonometry. Anybody want to do some trig? Probably not, right? But it's trigonometry, and it's just a fact. If you the three lengths that you have can only be configured in one configuration. Remember, you used to do like sine, cosine, and all that weird. That's what all that is. We're not going to deal with that. What we're going to use is principle that says if you have a triangle, there's only one way they can come together to make it much more accurate when we go to look for and tape out our set. Okay, so I pull down the screen. I turn it on. Okay, and in this particular instance, we're using Vectorworks. So here's the exact same set in our modest theater. The way this whole thing works, right, is that I'm going to be basically creating a series of triangles. And these series of triangles are going to show us where these points are. So I'm going to demonstrate by actually drawing a triangle. If I just click on a polyline tool, and I go from the upstage edge of our proscenium arch to that point, that end point, back over to the other stage of our proscenium arch, the upstage edge of our proscenium arch. And if I complete this, I've made a triangle. Does that make sense to everybody? That means if I know the length of these two legs of this triangle, the length of this leg of the triangle and the length of that leg of the triangle, I can find that point in the theater, because this leg of the triangle is never, ever going to change unless we do a renovation to the theater. Okay, so all we're doing is making a bunch of triangles and using the principle that if you know the three lengths of a triangle, there's only one place in the world they can meet. Okay? I'll demonstrate it one other way, and I don't know if it's going to help or confuse. If it's confusing, you can let me know and ignore me. But if I use a circle, and I draw a circle from here to there, that's the radius of the circle. The circle represents that exact length, right, all the way around 360 degrees. If I draw another circle from here to there, it's sort of proving my point. They can only intersect at one point. That's that distance, that radius, those two radiuses, every possible configuration in the world from those two fixed points, and see how there's only one place where they cross. Does that make sense? Does the circle demonstration help or hinder? Sometimes people get a little confused when I start drawing circles. So the way that we prepare to tape out is really very simple. In Vectorworks, we're going to use this tool right here, which is the unconstrained linear dimension tool. And with smart points turned on, it means we'll snap to things. I can just go to this corner, and you see how it highlights red? If I click there, that starts my line, and then it's going to snap to that endpoint. I'm going to click again, and then when I pull this down, it tells me what that dimension is. It's 11'6" and 3/8 of an inch. If I repeat that exact same process from here, from the other side, all I've done is figured out what the lengths of those two legs of the triangle are. Does that make sense? If I put my triangle back in, I was sneaky and I pre-drew the triangle. Right? All I've done is measure those two lengths, but drawing the triangle doesn't really help much, right? It just gets in the way. And that's all there is to it. Once you've drawn these two distances in Vectorworks, you know what they are. So then we go into the theater with two tape measures and two assistants. One assistant stands at the upstage edge corner of the stage left, right edge of the proscenium, and the other assistant sits at the upstage right corner of the proscenium where the plaster line is, and they hold the tape measure there. The stage manager then would take this tape measure and pull it out until they have it at like 6'7", so they have extra. And then they would take the other tape measure and pull it out. Cloth tape measures are better than metal ones, by the way, for this, like 50-footers, to 25'2" and 3/8. And then if you try to get those two to line up, lo and behold, there's only one place in the world where they will cross. And it's right there. So when you figure out where those two pieces cross, you put a piece of tape. You put a little X of tape. And that's that point. And what we do is we repeat this forever. I'm going to delete these now so it doesn't get messy. And we can talk about ways to do this beforehand and keep it neat. But I've deleted those because I've done them. You could actually just do, if you had a third ASM, You could actually do this in the theater in real time rather than prepping, but I like to get prepped. So if we're going to find the next point, it's the same thing. We figure out what that length is and what the length from this corner, the upstage corner of the pro is to there. And there are those two lengths. And there's only one place on stage where those two lengths will cross. So then you put your tape measures, you find out where they cross, you put a piece of tape. What I'm going to do is sort of demonstrate what I'm talking about here with this. Actually, I'll do a little circle, and I'll fill it. So if we just figure out where this point is, right, and we figured out where that point is, and then we figure out where this point is down here, which we haven't measured, but I'm assuming that you understand the process now, right? I'm going to delete these. And I'm just going to do some Vectorworks-y stuff for a second, so just to make it easier for you to understand. Put this on the none class. Okay, so now what we can end up with in this case, if we're just taping out on stage, that's my active class, right, is that we end up with pieces of tape on stage. And then all we do is take a piece of another piece of spike tape, and we have our ASM hold it at this point, and we stretch the tape out until it goes to that point, and then we take another piece of tape, and we stretch it out to there. And see how we're now starting to get our set? And if I come back in and turn it on, because math works every time it's tried, you can see I'm exactly where I want to be. This works remarkably well. This is how we tape out a set. And it doesn't matter whether it's a free-form set with floating pieces, like our upcoming production of Skin of Our Teeth, right? Or whether it's something like this that's a box set. If we just find all these corners by figuring out what the distance between each of the two, right? From each edge of the upstage edge of each corner of the proscenium. Once we figure out where those parts are, and we turn this on, right, now it's incredibly easy, to use the wrong tool, to draw circles, right? It's super easy to go from here to the center point, and there you go, okay? Now, when it comes to the doors, I didn't put windows, but doors are windows. And if you had furniture in the middle here and you want to spike the furniture, you do the same thing. You just calculate the two corners of the furniture, and hell, you could just put the piece of furniture there, right? You could do spike marks. You could pre-spike your furniture, technically. When it comes to the doors or windows or anything along the wall, you have a couple of options. You could do exactly what we've just did, right? We could find this corner of the door and that corner of the door using triangulation. A slightly simpler method and would be that to measure here and say, how far is the door from the end? How big is the door? It better be a 3-foot door, or Vectorworks is lying to me. No, that's a Michael error. It's a snapping error, not a. No, it's not. Oh, that's a. Right, and then we go ahead and we actually only need those two measurements, right? So 3-foot one. That's why. Look, see, math. Is it 3 foot to the inside of the jam? It must be. I'll stop in a second. All right, I'll stop. Okay. We can do it that way, and then after we get our set taped out, we can just measure along the piece of tape 1 foot 11.5 inches and make a mark. Does that make sense? Make sense, Bovians? And then measure the 3 foot for the door opening, right? And then we cut the tape and we bend it and make the door opening. That should make sense to everybody, right? Is that how you do it? right? So you do what we would do if this is a piece of tape, we come along and take another piece of tape and draw a really rough perpendicular line here. I can actually do this in Vectorworks, which will be fun. And a rough perpendicular line in there to sort of indicate that there's a door. And then we would take and actually, we would rip the tape right there. I want to do this. It's going to get mad at me. That's the cut tool, isn't it? That's trim. I want cut, split. Trying to split this. I don't know if it's going to let me. Sure. I don't care. And you can cut, you would cut the tape and then you rotate it out, right? And then you'll have your door. So either way works for finding the doors. It seems like a lot more work with the tape measures to try and get to where the corners of the door are. What I have a tendency to do is what we just did here, or I advocate this, is that you just go ahead and get your outline and then measure along your existing walls and put your doors in. Okay? Does that make sense? It's not hard at all. And in fact, it's easier than trying to do the over and up method because there are no lines to snap. There's no worrying about things being perpendicular. It's just you need two people. Actually, I say you need two ASMs to hold the tape measures, but I put screws in the ground or nails in the ground and hook my tape measure on it so it pivots. And I've done it by myself. Does anybody have any questions on this? How it works, the process? Or why we do it that way.
Well, it does make sense, but I think I'll understand a lot more once we actually do it, and once we can, like, physically do that. But so far, it does make a lot of sense.
All right. So that's it. It really isn't all that difficult.